Okay, so this lecture will cover sections 2.1 and 2.2 from chapter 2. So one thing before I start covering the material is that in this lecture, in this video, you will have to complete an activity before we meet next class. So I will be giving you information, material in this lecture, and you need to complete this activity because this material, this information will not be given to you again during class time. Okay, so make sure that you have a paper and a pen so you can complete this. Okay. So if we're looking at the picture here on the screen, why did I choose this picture? Well, if we are looking at what the general purpose of doing statistic is. So whenever someone is conducting a study or a research project, the main objective is to draw a conclusion using numbers. So we want evidence-based conclusion about certain phenomena. The conclusion, the phenomena will vary depending on the topics, the research question, but you want those conclusions to be evidence-based. Okay, so that's the main objective. That's the outcome of doing research. The problem is, before we actually get to this outcome, there are a lot of steps that we need to complete, and often those steps are not as glamorous than looking at numbers and playing with numbers and making conclusion. Okay, but they are just as important as performing or using formulas to generate numbers. Okay, so if we're looking at the first step involved in each research project when it comes to the analyzing data part, is that if we want to be able to draw a conclusion, we need data. Okay, so we need to collect data, so this will become the raw data for each participant using either a sample or a population. Okay, so it doesn't matter whether it's sample or population, you need to collect data that will create, or that will be the basis of your data set. Okay, so that's the first step. If you don't do this, there's nothing for you to analyze, so you can't run any statistics. The type of data that you will find in your data set will be either qualitative data or quantitative data. So this is something that we covered already. Okay, so what will happen if we are focusing on qualitative data here? What will happen in your data set? You will have a bunch of words, a bunch of numbers for a number of different participants. And this is really hard to make sense of. So we need to find a way to get a general sense of what the raw data suggests. Okay, and in order to do this, we use a tool called a frequency table or a frequency distribution. So it's the same thing. So before I tell you or explain what a frequency table is, let's use an example, okay, to generate a frequency table. And this example can be found in your textbook. So let's imagine that I have a sample of 50 students and I ask them the following question. Which type of computers do you use for schoolwork? And I give them the options tablet, notebook, laptop. So the difference between a notebook and a laptop is that the notebook is smaller, or do you use a desktop? Okay, so I asked this question 50 times, and these are the answers that I got from my 50 participants. Okay, so each participant actually chose one category or one answer. So it's really hard by looking at this table to know which answer come up the most frequently. Okay, so what we need to do here is to create a frequency table to make this question easier to answer. So what is involved or what is included in a frequency table? Well, what you need to know is, regardless of the type of frequency table that you are dealing with, there will always be a minimum of 2 columns. Okay, the first column will not change. The first column involves categories, or later on we'll look at bins, but categories or groups. Whereas the second column includes the actual frequency, and there are different types of frequency. So if we look at the first type here, absolute frequency or just frequency by itself is basically the number of time each answer is reported. So you go in your table, you count how many times a specific answer was mentioned. Okay, so if we go back here to our table, I want you to look at this table. You'll have to pause this video to count, but I want you to create a frequency table with those options. Okay, so let's do this. Okay, so let's try to create our frequency table. As I just said earlier in the video, A frequency table has a minimum of 2 columns. So in the first column here, you can see the different categories or possible answers. So we have desktop, laptop, notebook, or tablet. And in the second column, we will actually have the frequency. So if we were to count how many students reported using their desktop, we would find a value of 11. For laptop, we would get 23 students. For notebook, we would have 9 students, and for tablet, 7 students. So those are the actual frequency. So if we were to add all those numbers up, we would get a total of 50, which 50, if you recall, represents your sample size, which N is the symbol used for sample size. So there you go. So doing a frequency table is easy like that. So we are back with our raw data. Now what we will do whenever we are dealing with any kind of variables, whether it's qualitative or quantitative, we can add a third column to our frequency table. And the third column is called relative frequency. Okay, so a synonym for relative frequency is the word proportion. So basically, what is a relative frequency? Well, you take the actual number of participants that reported a certain category, and you divide this number by the total number of participants. Okay, so relative frequency, you take the actual frequency divided by the total number of participants. So let's look at our data here, and we will try to add one more column to our frequency table. Okay, so here we have our table again. So I added the third column, which is relative frequency. And remember what the definition of relative frequency is you take the number in the frequency column and you divide it by the total number of participants. So basically 11 divided by 50, and it would give you a relative frequency of 0.22. And you could do that's the same thing for each category. So 23 divided by 50, you would get an answer of 0.46. For notebook, you would get 0.18. You would get 0.14 for tablet. Okay. Another difference between relative frequency and absolute frequency is if you add all of these numbers up right here, you get a total score of 1. Okay, so the total of the column labeled frequency always adds up to the sample size, whereas the relative frequency always adds up to 1. Okay, so now let's try to look at a frequency tables to summarize raw data from a quantitative variable. The actual columns will be the same. So in the first column we'll have categories, in the second column we'll have frequency, and the third column will be used for relative frequency. Okay, so this doesn't change. However, there is one major difference between quantitative and qualitative data. To better understand, let's look at a specific example using a quantitative variable. Okay, so let's say we ask 65 students, how much change do they have in their pocket? Okay, each student has to answer this. So this is an actual number that they will report, which makes this variable quantitative. Okay, so if we are focusing here, disregard the fact that it says emissions for 65 vehicles. Let's pretend that this is actually change that people have in their pocket. Okay, so we have 65 scores. Can we just use those scores to create our table? The answer is no. Because imagine, if you look at the first value in the table, $1.50, and you look quickly over it, there's only one participant that reported having $1.50 in their pocket. So basically the frequency table as we know it would be very long, a bunch of numbers with often only frequency of 1. Okay, so rather we need to bind some of those data. So basically we need to create groups to better summarize the data. Okay, so let's imagine that we want to summarize those data using 7 groups, 7 bins. Okay, so now if I go back to my data and I say, okay, create your group, where would you start? Well, this is pretty hard to determine, but there are some very useful guidelines that can help you determine the boundaries of each group. Okay, so here are the guidelines. You can find them on page 51 of your textbook. Okay, so first of all, every data must be covered. They must fall into one of the 7 groups. Okay, that's quite important. Second of all, the groups or the classes, they cannot overlap. They need to be exclusive. So for example, if I have a group that is 20 to 25 and my next group is 25 to 30, the number 25 falls within two groups. So I cannot do this. The classes or the groups must be of equal width. Okay, so the same number of options need to fit in or to be considered in each group. And finally, you can't have any gaps in between classes, even when you don't have observation fitting specific groups. Okay, so the data must be continuous, or the groups must be continuous. Okay, so this is the data here. So where to start? Well, we have 7 groups. We know some characteristics of the groups, but like what value should we start with? Okay, if you look at this table here and you find the minimum value can be found in the first column, last row, so it's 0.25. If you look at the biggest value, you look at the third column to last, second row, and you have a value of 6.64. So those are our two values. Okay, so here, minimum value 0.25, maximum value 6.64, and we want 7 groups. So a very easy formula to determine how big each group should be. So this is called the class width. Okay, so class width. So to determine this, you use the formula maximum value minus minimum divided by the number of groups. So if we do this, we have 6.64 minus 0.25, and you divide it by 7. It will give you a value of 0.9. Okay, so that's how big it should be. But 0.9 is not a very nice number. It's not a whole number. It's not round. So what we can do is we could say, okay, the class width will be 1. Okay, the minimum value is 0.25. So basically nothing stops us from starting at 0. Okay, so our minimum value for the first group will be 0, and we have a class width of 1. Okay, so this is the table with everything. You have the data. Now, you can pause this and try to actually create 7 groups. The first group will start at 0. It will have a group width of 1. And then compute the frequency for each group as well as the relative frequency. Okay, so here I have my 7 groups. Like I said, the first group would start at 0 and it would have a width of 1, so we would get 0.099. The second group would start at 1 and would go to 199 and so on. Okay, so if I recall, or if I count the frequency, so the number of answers that fall within the first group, I would get a frequency of 9. For the second group, I counted 26. For the third group, I counted 11. The fourth group, I counted 13. Then I counted 3, 1, and 2. And if I am correct, if you add all of these up, you would get a total score of 65, which is your sample size. Now I can compute the relative frequency. So if I take the value of 9 and I divide it by 65, I would get a score of 0.138. For the second group, I would get 0.400. The third group, 0.169. Then I would get 0.200. I would get 0.046. 0.015 and 0.031 for a total of 1.0. So there you go. We have our relative frequency tables for quantitative variable. Okay, so recall that at the beginning of the lecture, I actually mentioned that you would have to complete something in order to get ready for next class. Well, this is it. So basically, I will give you two variables, and I want you to create 2 different frequency tables. And you will need those tables for activities in class. Okay, so the first variable, qualitative variable. Let's imagine that we are asking 20 participants, what type of cell phone do you use? There are 5 possible answers. So A, iPhone, B, Samsung Galaxy S4, There's HTC1, Motorola Moto X, and LG G2. Okay, so the score of the 20 participants are listed as below. Okay, remember that the letter corresponds to an actual category. So pause the video here and compute your frequency table. For my next variable, a quantitative variable, we have a sample of 40 participants. And let's pretend that we're asking them, how many hours per week do you work? Okay, so basically I want a frequency table with this raw data, and I want you to use or to create 8 classes. So once again, pause the video and create your frequency table. Remember to bring those 2 tables in class for activities.